Hello friends, myself Dattatreya Jadhav. I am from HM College, Karad, which is a branch of registration Samstha. Students, I am your mathematics teacher. Today we are going to start a new chapter of 11th standard, that is sets and relations. You are already studied the chapter sets in 9th standard. So, what is meant by a set? A set is collection of well-defined objects. For example, tell me number of days in weeks. There are 7 days in weeks. Which are they? They are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and adding Sunday. Sunday don't add twice. So clearly it is a set because the answer of that question, the days in a week, is clearly Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or someone saying Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Order is immaterial, but all the objects are unique. All the objects are unique. Such a type of examples are called as set. For example, again I can consider another example. Happy students or happy persons in your city. Happy person in your city. It is clearly example of set? No, because happy means not clearly defined. Who is he? That person who is rich, which is happy, or that person who is poor, but he is doing very well in job. These type of persons are happy. We clearly don't know which person is happy. Which person is happy? It is clearly not well defined. So, the set of happy person is not an example of set. Third, I can take here one more example. Natural numbers less than 5. If I ask the natural numbers less than 5, the answer is 1, 2, 3, 4, 5. Less than or equal to 5. I can correct this example. Natural numbers less than or equal to 5, or natural numbers less than 6. Clearly the answer is 1, 2, 3, 4, 5 from all of them. So the answer is unique. It is well defined. So this example is clearly example of a set. So first we define what is meant by set. Set, the collection of well defined objects. The collection of well defined objects is called as set. Sets are usually denoted by capital letters. Capital A, capital B, capital C. Okay. Now, the objects, Sunday is object, Monday is object, Tuesday is object, Wednesday is object, Thursday is object, Friday is object, Saturday is object of that set. 1 is object, 2 is object, 3 is object, 4 is object, 5 is object. These objects in the set are called as elements of the set. So, what is meant by elements? Elements is nothing but the objects in the set are called its elements. So objects in a set are called its elements. Here objects are 1, 2, 3, 4, 5. These are called as elements of the set B. The objects in the sets are denoted by small letters. Objects in the sets are denoted by small letters. Next, if look at here. Here B, set B is 1, 2, 3, 4, 5. So 1 belongs to 1 is in B. 1 is in B. So I can write 1 belongs to B. If 1 is in B, then we say that 1 belongs to B. That notation is used to denote belongs. Okay, but look at here, 0 is in B. 0 is in any level. 0 is in B. No, so I can write 0 does not belong to. This symbol is used to denote does not belong to B. Does not belong to. Notation is that, and for belongs to we use notation E. Type E. Okay. So these are two definitions. First one is a set. Set is a collection of well-defined objects. Second one is element. Element is nothing but the objects in the sets are called its elements. Clearly, here new two symbols are here. First one is belongs to. That symbol is used to denote belongs to. Clearly, 1 is in B. 1 is in B. So I can write 1 belongs to B. 2 is in B, so I can write 2 belongs to B. 3 is in B, I can denote 3 belongs to B. But look at here, 0 is not in B, so I can denote 0 does not belongs to B. Now, moving to next definitions or next point. The next point is representation of the set. Next point is a representation of sets. There are mainly three types to represent a set. First type is a roster method. Second type is set builder method. Third type is Venn diagrams. So look at it. The representation of sets. We represent the set, any set in any one of these three methods. By using roster method, by using set method, or by using Venn method. Suppose here is an example of A. A is the set of natural numbers less than 5. Set of natural numbers less than 5. You may remember here capital N is nothing but set of natural numbers. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, so on. After that, whole numbers. Set of whole numbers is denoted by W. W is set of whole numbers. Yes, it starts with 0, 1, 2, 3, 4, so on. Third one is type of numbers is integers. Integers, the set of integers is denoted by capital I. I is nothing but set of integers. Set of integers is, yes, so on that, -3, -2, -1, 0, 1, 2, 3, so on that. Means natural numbers with their negative numbers including 0. After that, rational number is there. Set of rational numbers, the numbers which are in the form of p divided by q, where p and q belongs to integers. Next type of set is numbers is real numbers. Real numbers, all numbers, natural number, whole number, integers, yes, rational number, all irrational numbers, all these are in real numbers. So these are the symbols to denote, yes, natural number, n, w, whole number, integers, I, q for rational numbers, r for real numbers. So set of natural numbers less than 5. Now look at it. In roster method, we list all the elements of this set in curly brackets and separated by commas. म्हणजे काय करतो आपण या लिस्टिंग मेथड मध्ये एक लिस्ट करू. या रोस्टर मेथडला सेकंड जे नाव आहे ते आहे लिस्टिंग मेथड. फॉर एक्झाम्पल, तुम्ही जर मार्केटला जाणार असाल तर तुम्ही काय करता, एक लिस्ट करून काय घ्यायचं आहे त्याच्यासाठी. तसंच रोस्टर मेथड मध्ये काय करतोय आपण, तर लिस्ट करतो. आता मला सांगा, सेट ऑफ नॅचरल नंबर्स लेस दॅन 5. नॅचरल नंबरचा सेट आहे 1, 2, 3, 4, 5, so on. But less than 5. Less than 5 means what? Therefore, A is equal. There is term 1. 1 is less than 5. 2, 3, 4. So these are the objects 1, 2, 3, 4 less than 5 natural numbers, and we separate these numbers by commas and we write all these numbers in curly brackets. This type of representation of set is called as the roster method. Roster method is also called as listing method. Okay, now in set builder method, we build up a formula. And from that formula, all the elements are uniquely represented. Set builder method, it is also called as formula method. In this method, we use a formula to represent this set. Set of natural numbers less than 5. I can write this as A is equal to, in curly bracket, it is a set of numbers, so I can denote that numbers by x. I want to write their formula, so I can write there x. It is set of all x such that standing line is clearly read as such that set A is set of all elements of x such that x belongs to natural number. All x are natural numbers. Here all the numbers are natural numbers, but these numbers are less than 5. So I can put a condition here such that x is less than 5. X is less than 5. Alright, right here x is less than or equal to 4, which is also correct. Okay. In roster method, we list all the elements of the set into curly brackets and separate these elements by commas. And in set builder method, we build up a formula, and from that formula, all the elements are uniquely represented or uniquely represented. For example, I can take a natural number less than 1. First, I can write here 1. Second natural number 2, 3, 4, 5. 5 is not less than 5, so I cannot write here. Okay, and here is another method of representing a set. That method is called as Venn diagram. The scientist Venn introduced that diagrams. So this representation is called as Venn diagrams. Venn diagrams is nothing but the pictorial representation. Pictorial. What is meant by pictorial? Like a picture. Pictorial means what? Like a picture. Pictorial means like a picture. The pictorial representation of a set is called as Venn diagram. Generally we use closed geometrical figures. Which are there? Closed geometrical figures. Sometimes we use square. Second closed geometrical figure is rectangle. Sometimes we use circle, oval, triangle. Okay, these geometrical figures are used to represent a set in Venn diagram. Now, I want to write that set of natural number less than 5 in Venn diagram. So I can write here. I use here a circle to represent that set A. And how many numbers are there? 1, 2, 3, 4. For that, I plot here 4 dots. And that first dot represent 1, 2, 3, 4. Like that. So, Venn diagram is nothing but the pictorial representation of set is called as Venn diagrams. Remember, there are 3 types or 3 methods to represent a set. First one is roster method. In roster method, we list all the elements. For example, again I can take here one more example. Second example is here. This one is our first example, and I can represent the second example in also roster, set, builder, and Venn diagram. Suppose this second example is B set of even natural numbers less than or equal to 10. Even natural numbers less than or equal to 10. We know that natural numbers are 1, 2, 3, 4, 5, 6, 7, so on that. But even natural number, even means 2, 4, 6, 8, 10. So I can write that set B. I can write that set B in roster or listing method as 2, 4, 6, 8, 10 less than or equal to 10. That's why I am writing here 10 equal to 12. I can't write because 12 is greater than 10. So this representation is called as roster representation. Next, set builder method. In set builder method, we write this as it is a set of all elements Generally, we denote that all elements by x. It is a set of all elements of x such that all these are natural numbers. So I can write here x belongs to n. X belongs to n. All these are natural numbers. X, second condition is what? X is equal to, formula is 2n. Formula is 2n. Even numbers, for even numbers, 2 into n. All x such that x is equal to 2n. I can write this as x is equal to 2n, even number, and n belongs to capital N. And here is the condition: n is less than, yes. If I can take n is equal to 1, we get 2. N is equal to 2, we get 4. N is equal to 3, we get 6. When n is equal to 4, we get 8. When n is equal to, yes, 5, we get 10. So I can write here less than or equal to 5. So in set builder, we build up one formula: set of all x such that x is equal to 2n. N belongs to capital N, and n is less than or equal to 5. Or simply you may write here it is a set of all x such that, in wording you may write here set of all x such that x is even natural number less than or equal to 10. Even natural number less than or equal to 10. And in, yes, in Venn diagram we represent that set B as, I use here another geometrical figure. Close the geometrical figure. I use here a rectangle to represent set B. Set B is what? Of elements 2, 4, 6, 8, 10. So I plot here how many dots? 5 dots. This one is 2, 4, 6, 8, 10. This type of representation is called a Venn diagram. Okay. Now we are moving to our next definition, that is cardinality of a set. Cardinality of a set. Or number of elements. For example, here is set like this as 1, 2, 3, 4, 5. How many elements are in A? Yes, 1, 2, 3, 4, 5. There are how many elements? 5 elements. So number of elements in A is what? Number of elements in A is 5. And that number of elements in A is called as cardinality. Cardinality of a set, and it is denoted by n of A. N of A is nothing but number of elements. Number of elements of set A. Yes, how many elements are there? There are 5 elements. So cardinality of that set is nothing but n of A is equal to 5. Cardinality is nothing but number of elements of the set is called as cardinality. Okay. Now next, the next point is there are 2 nodes. If I can write A as 2, 4, 5, 3, 1, then these 2 are same. Order is immaterial in set. And second one is, if any element is repeated, for example, I can write this as 1, 1, 2, 3, 4, 5. Here 1 repeat twice. Don't write twice. Don't write twice. Take only ones. One can take in only once. 1, 2, 3, 4, 5. If any object is repeated in the set, then write only once. Okay. Now, next point is, here is one of the most important type in the set is nothing but types of sets. Types of sets. There are, I think, 11 up to 10 to 11 types of sets are there. First one is, the first type of set is empty set. Empty set. That set is also known as void set, or which is also known as null set. Null set. It means that the set which is empty. Empty set. The definition of empty set is what? A set which contains no element is called as empty set. For example, I can write here one example is here. A set of all x such that x belongs to natural number and 2 less than x less than 3. Write the natural number. X belongs to natural number which is lies in between 2 and 3. There is no such a type of what? Number. So I can write here in curly bracket void, empty, null. But that type of sets are denoted by this letter. This letter is called as phi. These type of letters are used to denote empty set, void set, null set. So number of elements in empty set is what? 0. Cardinality of empty set is 0. Now moving to our next example, next type of set, that is second type of set is singleton set. Singleton set. Single. What is meant by single? Only one. Okay. So singleton set is nothing but a set containing only one element. A set containing only one element. That set is called as singleton set. For example, I can write here one set. Suppose that A is equal to yes 1. Curly bracket 1. Here, how many objects are there? There is only one object. So what? A is called as singleton set. Number of elements in set is equal to 1. When of A is equal to 1, then that set is called as empty set. Take one another example. Capital of India. The capital of India is New Delhi. If I can represent that set by B, then B can be written as set New Delhi. Okay. So how many elements are there? New Delhi is one element. So n of B is also 1. So I can write n of B is equal to 1. Cardinality of one singleton set is always 1. A set containing only one element is called as singleton set. Now, next, third type of set is finite set. Finite set. A set in which the number of elements are countable or are finite. A set in which number of elements is finite is called as finite set, or a set in which the number of elements are countable. Such a type of set is called as finite set. For example, here I can natural numbers less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't write 10. How many elements are there? There are 9 elements. So these numbers are countable. 1 to 9. These are countable numbers. So that set is a finite set. That set is finite set. Now next definition or next type of set is infinite set. Infinite set. What is meant by an infinite set? A set which is not finite. A set which is not finite. That set is called as infinite set. Or a set which is not countable. Which is not countable is called as infinite set. For example, set of natural numbers. How many elements are there? How many elements are there? Don't know. How many elements are there? Don't know. These elements are infinite. So I can write set of infinite set. Take one example is here. Set of natural number. Set of real numbers is also infinite set. Set of integers is also infinite set. Set of whole number which is also infinite set. Set of rational number which is also infinite and infinite set. Okay. Now next definition or next type, subset. Subset. For denoting subset, we use this notation. We use this notation to denote subset. Look at it. One example is here. A is equal to 1, 3, 5. And B is equal to 1, 2, 3, 4, 5. Okay. Here clearly we see that all the elements of set A, that is 1, 3 and 5 are in set B. So I can write A is subset of B. A is subset of B. A set capital A is said to be subset of set capital B if all the elements of set A are in set B. Then we say that A is subset of B, and the notation, in notation we write A is subset of B as A C underline B. It means that if I can take another example is here. If I can write C as 1, 2, 3, 4, 5, then what? C is also subset of B. C is subset of B. The number of elements in this set are equal. Then also we say that these are subsets of C is subset of B. Elements are equal. That's why that notation is given under them. Next, after subset, it's superset. Next definition, next type of set is superset. And the notation for superset is this one. Okay. Look at it. Clearly in last example, A is equal to 1, 3, 5 and B is equal to I can take here 1, 2, 3, 4, 5. Clearly A is subset of B. When A is subset of B, then B is called as superset of A. B is called as superset of A. म्हणजे इथे काय लक्षात ठेवायचं आहे, A हा जर B चा सबसेट असेल तर B ला सुपरसेट म्हणायचं आहे A चा, and for denoting superset this symbol is used. For denoting superset this symbol is used. Now next type of set is seventh type, proper subset. Proper subset. Here remember phi is subset of all sets. Phi is clearly subset of all sets. For subset phi is a clearly phi is subset of all sets. Now for proper subset, which set is said to be proper? For proper subset, I can take example is here A is equal to 1, 3, 5, B is equal to 1, 2, 3, 4, 5. Then clearly A is subset of B. Is subset of B, but A is not equal to B. Means B contains one more element. One more element which is not in A. Here B contains the elements 2 and 4 which are not in A. So I can write this as A is proper subset of B, and notation for denoting proper subset is that one, C. A is proper subset of B, and remember A is a non-empty set. A is a non-empty set. जर A हा non-empty set असेल आणि B मध्ये असा एखादा एलिमेंट असेल, कमीत कमी एखादा, जास्त किती असतील तरी चालतं, कमीत कमी एखादा असा जर एलिमेंट असेल की जो ए मध्ये नाही, तेव्हा त्याला आपण काय म्हणणार आहे की प्रॉपर सबसेट. कोणाला? ए ला. कोणाचा? बी चा. ए ला बी चा प्रॉपर सबसेट असं आपण म्हणणार आहोत. ही झालेली आहे डेफिनेशन कोणाची? प्रॉपर सबसेट. नेक्स्ट आफ्टर प्रॉपर सबसेट, next definition is power set. 8 number definition is power set. Power set of A is denoted by P of A. Power set of A is denoted by P of A. Look at it. Suppose I can take here example A is equal to 1, 2. Now tell me the subsets of A. How many subsets of A are there? Yes, clearly phi is subset of all sets. So phi is there. Or you can write only curly bracket which is empty. Okay, this one first set. Second one, 1 is also subset of that set A. 2 is also subset of that set. And remember, itself is also subset. So that set 1, 2 is also subset of A. So power set of A is defined as the set of all subsets. The set of all subsets of a given set is called as power set of A. For example, if A is equal to 1, 2, then I can write power set P of A is equal to curly bracket. First I can write empty, second one is 1, third one is set 2, and fourth one is set 1, 2, and we write all these subsets in yes curly bracket. So power, this is the definition of power set. Set of all subsets of. Look at here in A, how many elements are there? 2. Here in A, how many elements are there? 2. Now look at here in power set of A. In power set of A, how many elements are there? 4. Means if A contains m elements, if number of elements in A is equal to m, then number of elements in power set of A, number of elements in power set of A, which is equal to 2 raised to m. 2 raised to m. Look at it. N of A is equal to 2. So 2 raised to What is 2 raised to? It's 4. How many elements are there? 4. If A contains 3 elements, 1, 2, 3. If A contains 3 elements, the number of elements in power set of A is 2 raised to 3. 2 raised to 3, which is equal to 8. Now I write the power set of A. Power set of A. Which elements are there? Look at it. Clearly, pi is subset of all sets. Second one is 1, 2, 3. 1 comma 2 is subset of this set. Yes. 1 comma 3. 1 comma 2 comma 3. And last one is 1 comma 2 comma 3 itself. So I list all these elements in curly bracket here. So I can write power set of A is equal to first 5. You may denote this 5 or empty set. Empty set is denoted by like this. 5 curly bracket 1 curly bracket 2 curly bracket 3 curly bracket 1 comma 2 curly bracket 1 comma 3 curly bracket, yes, 2 comma 3 curly bracket 1 2 3, and I list all these elements in curly bracket and separate that elements by commas. So it represents power set of A. Okay. Next, after power set, I can define one more type. That type is equal sets. Equal set. The definition is, for equal sets, the definition is two sets A and B or X and Y are said to be equal if all the elements are same. If all the elements are same, for example, X is the set of letters of the word above. X is the set which is nothing but letters of the word above. So we define X is equal to, yes, A comma B. Now second example is here. Y is nothing but set of letters in the word Baba. Set of letters in the word Baba. Therefore, Y can be represented as curly bracket B comma A. So look at here. In this case, all the elements of X are equal. N of X is equal to N of Y, and elements are same. Such type of sets are said to be equal sets. Next definition is equivalent sets. Equivalent sets. Two sets A and B are said to be equivalent if it satisfies the condition N of A is equal to N of B. For example, A is equal to 1, 2, 3, and take another example, B is equal to 3, 4, 5. Here cardinality of that set is N of A is equal to, yes, 3, and N of B is equal to 3. So these two are what? Equivalent sets. These two are equivalent sets. Now last type is universal set. Universal set. Last type. A set, capital X, is said to be universal set, or for denoting universal set we use capital letter U. A set capital X is said to be universal set if under a particular discussion all the sets in the given example are subsets of that universal set. That is, x. For example, u is equal to, take one example is here, u is equal to 1, 2, 3, 4 up to 10. Okay, universal set I can denote by 1 to 10, and in that example 3 sets are defined. First set is 2, 4, 6, 8, 10. Second one is 1, 3, 5, 7, 9, and last one is 5, 6. Look at here. For this example, A is subset of U, B is also subset of U, and C is also subset of U. So that set U is called as universal set. For universal set, we consider natural numbers, whole numbers, integers, quotients, real numbers. Okay. So students, today in this video we learn about sets, definition of set, and types of sets, and representation of set. So students, I hope you understood these definitions. Thank you for watching the video.